function notation and problem solving. So in this lesson, we're going to solve problems using function notation as opposed to using XY notation. So in lesson 3, the assignment question number 6 was on long-last candles. Candle manufacturer found that their candles melted according to the formula H equals negative 2t plus 12, where H is the height of the candle in centimeters after t hours. This is an equation. The relationship between the height and the time is an equation. We could actually put this into function notation because there is only one, there's a one-to-one input to output ratio. So as long as there's one input only has one output, I can do function notation. So what I can write instead of H equals negative 2t plus 12 is I can use the formula H of t, so height as a function of time is equal to negative 2t plus 12. Really, that's what it means. So then H of 4 would be a simplified way of saying find the height after 4 hours. So, candle manufacturers, we now have function notation, H of t equals negative 2t plus 12. Use a graphing calculator to sketch the graph of the function and show the graph on the grid. So if I grab my graphing calculator and I type this in, my calculator does not do function notation. It does XY notation. So I can't use H of t. I just use y equals and negative 2x plus 12. If I put this on a standard Windows setting, I see this, I see where it crosses the x-axis, but I don't see where it crosses the y, so I need to move or adjust my Windows settings. This in here represents negative time, so I don't need a lot of negative time. This is negative height. Again, once the candle gets down to the bottom, it's gone. The candle doesn't get a negative height. So again, I could adjust my Windows settings. I could go from 0 to 10. That will be fine. My y's, I could go from 0 and I could try 15 and see what that does. And now I have a graph where I see both intercepts. So that's the graph that I could sketch. And when I sketch this graph, I can label it H of t equals negative 2t plus 12. And I can also include what my Windows settings were. So my Windows settings, let's put them over here. My x's went from 0 to 10, going up by ones, and my y's went from 0 to 15, going up by ones. So B says determine the value of H of 5. How can I use the calculator to find H of 5?
Put your second 5 over this. I was thinking of just intercept. You could just go trace 5.
You go trace 5. Okay. So trace 5, enter. You were thinking the other way, right? The height of 5.
Yeah.
So this is after 5 hours. What's the height? 2. So H of 5 equals 2. So then the question says, write the words, write in words the meaning of this.
After 5 hours, the candle will be 2 centimeters.
Yeah.
2 centimeters upward.
So after 5 hours, the candle is 2 centimeters tall or in height or long. Okay. Evaluate the following and explain each of their significance. So evaluate implies that you have to show some work. So we're going to do these algebraically. So H of 0 means negative 2 times 0 plus 12, which equals
12.
12 what?
Centimeters.
Because the candle hasn't been lit.
Means the candle hasn't been lit. So the starting height of the candle is 12 centimeters. Okay? H of 6, which would be -2 times 6, which is -12 plus 12 is, what does this mean?
The candle's been lit for 6 hours, and that's completely burned out.
Okay, so candle burns out. In 6 hours. Okay? And then the last one, H of 8.
Candle actually caught the table candle sitting on the fire, and now it's burnt.
So what does this equal?
4, -4.
-4.
I guess it wouldn't be 7.
So in the context, does this actually have meaning in the context of our question?
No,
Unless there's no hole.
There's no
Still,
So there's no context. I can't have a negative candle height. And no, it did not burn through the table and down onto the floor.
aw,
No,
pretty cool.
we didn't start anything on fire. Okay, so how long will it take the candle to burn to a height of 7 centimeters? How would I find that one out?
you could put like a Y2 at 77.
Okay, so I can let y2 equal 7, and then what would I be finding?
Interesting.
And then I'd find the intersection. Okay, suppose I didn't have this on my graphing calculator. How would I do this the old-fashioned way?
The algebraic way.
How would I do it the algebraic way?
Put it into your,
Inches to 2.
put in your equation. 0 equals -2t.
So 7 equals -2t plus 12. How would I solve this?
So subtract minus
So minus 12 on each side. What's 7 minus 12?
-5.
So -5 equals -2t. So what would t equal? And 2.5 what? Hours. So it'll take 2.5 hours for the candle to get to a height of 7 centimeters. And F says suggest an appropriate domain and range for the function. So what is measured on my domain? What values are measured along this axis? Time. Okay? So what's an appropriate window setting for my time? What was this point right here?
6.
6.
0
0 to 6. So I could use interval notation because time could be measured continuously. Because the candle burns continuously, right? And what's along my vertical axis? Height, which if we're using function notation, this would be h of t. So what's my height?
12 to 0.
12 to 0 or
0
0 to 12. Okay, so the questions for this assignment will be questions 1, 2, and 4. Lesson number 11, interpreting graphs of functions. So the Carter family is driving to the Yukon for a family vacation, and this graph represents the amount of fuel in liters in their gas tank on the first day of the journey compared to the time of day. So if you look, they left at 7 o'clock in the morning, 700 hours, and they went until what time in the afternoon? 5 o'clock. So 1700 minus 1200. So I start off with 50 liters, I go down, go across, go back up, come down, go across, go down again, come back up, and then go down. So between each of these sections, we're going to describe what happened. So what is happening between A and B?
They're burning gas.
And why do you think they'd be burning gas?
They're going too fast.
They're going too fast, or they're actually moving at all? Okay, so how long did they drive for?
How?
To what time? front of you. 1 tick mark, 2 tick marks, 3 tick marks.
About 10. 9:50.
No, let's just say they drove for 3 hours.
Yeah.
Okay?
How do you lose that much
We're-
gas in 3 hours?
$10.
It's 30 liters. Depends what kind of a vehicle they have.
Oh, unless you get bored.
So they burned 30 liters of gas in 3 hours. Would you say that the rate at which they were losing the gas was consistent? Yeah, because I've got this straight line. So I could say that they were driving at a constant rate for 3 hours. What happened between point B and point C?
They ran out of
They
fuel and pushed the
stopped.
vehicle.
Did they run out of fuel?
They
No, they
stopped
probably
at the gas
stopped and had
station,
to
Go to the back.
So they stopped. They didn't fill up with gas.
No,
They
got
just
food
stopped.
probably.
And how long did they stop for?
Just for like.
Oh, half an hour.
Okay.
So that seems like you're going for a drive and stuff.
So I don't know. They pulled over to a roadside turnout
They hit
and they
someone
had
with a head
a
body.
snack that mom had packed early that morning.
If they're pulling the trailer,
Maybe.
they probably just went into the trailer and ate food. We do that.
Okay. What happened between point C and point D?
They
filled
filled
gas.
gas. They filled the tank.
They added gas, so they filled the tank. And so at point A, was the tank full?
No.
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 Always fill your tank before you go.
Okay, so
It's
they
super
filled
hot out.
the tank
Then
with
you don't
fuel.
Why is that? So it'll explode.
Okay.
And you'll have gas leaking.
Now let's look from D to E.
It's a bunch of dirt on it.
Just light it on fire.
Easy.
Okay,
Oh my god.
let's go firebugs here. What is the rate of fuel consumption in liters per hour from point D to point E? So this liters per hour tells us how to divide it. How many liters of fuel did the vehicle burn from point D, which is at 60, to point E, which is at 25? Okay, so how many liters of fuel is that? Okay, 60 minus 25, so 35 liters. And how much time elapsed? So I was at, what, 10:30? So,
3.5.
and now I'm at 2 o'clock,
Yeah.
so 3.5 hours. Okay, so 3.5 hours, so liters per hour would be 35 divided by 3.5, which would equal
10.
10 what?
Liters per hour.
Liters per hour, good. Okay. What line segment would represent the car being filled for the second time?
5 people.
GH.
Because they were driving for 3 hours here.
Question D says calculate the total time the car's being driven. So what time did we start driving?
7.
7 a.m.
1700 hours. Should we start at 4?
And I went to what time?
1700 hours.
So how many hours is that?
5
5 hours. No.
It's 5 o'clock in the afternoon. How many hours did I drive?
No.
17 minus 7.
10.
10 hours. Okay.
You mean no math?
But they were.
But how
they
long
were
did I stop?
Yeah, they were stopped for about an hour and a half.
So I had that 1/2 hour stop that we already addressed. And how long did I stop here?
About an hour.
About an hour. Okay.
What were they doing there? Everything.
So 1.5 hours. So total driving time is how much?
8.5.
8.5 hours.
They should be going longer.
Okay. If fuel costs 85 cents a liter, calculate the cost of fuel used for the first day of the journey. So from point A to point B, how many liters of fuel did they use?
0.8
From A to B,
30.
30 liters. Okay. So A to B was 30 liters. And then we burnt gas from D to E, which we had already calculated up here, was 35. And then from F to G, how much gas did we burn?
And 10.
10, 25 to 15, okay? So F to G was 10. And then the last section was H to I. So how many liters did I burn from high? So I went from 60 to what?
50.
So how many liters is that?
85.
That's 10 liters. The total is 85. And the cost per liter is?
85.
Okay, so how do I find out the total cost?
Times by 1.5. Which is 72.25.
So $72.25 is how much it cost me to drive on the first day of the trip.
It's not bad.
Depends
Yeah,
how many
if only
kilometers I
gas
actually
If
drove.
only gas was still that cheap.
Yeah.
Yeah.
It's not bad at Costco right now.
Yeah, I know. That's what I saw.
Because it's 101 here in town, or 102.
Really good down the States. Let's just go around the States.
Okay. Class example number 2. I have a speed versus time graph. There are no numbers on this graph, but what can we infer as I go from this point to this point?
Slow down.
Oh.
There's a movement.
What's happening along this axis?
Um,
Time is doing what?
passing.
It's increasing. So this number here is going to be smaller than this number over here. And what can I infer about my speed?
You have increased it.
My speed's increasing. Okay. So what do I notice about this section in here?
That was constant rate.
Constant rate of speed, and then what?
Decelerate.
You saw a cop.
Okay. And what did you do?
You drove
Decelerate.
slow because you're stuck in traffic.
Okay.
And you got out of traffic, so you sped up. And you kept constant rate. And you got pulled over.
Then you got pulled over.
And then
Okay.
you
So there's various scenarios that you can come up with this. I think the scenario that was provided in here is from this point here. So in part 1, you were, let's say, driving highway speed. Or in Ty's case, you're speeding. And then from this section in here, so we'll call it section 2, slow down.
Slow down.
Ty's slowing down because he's going to see the cops. I'm going to slow down because there's construction.
Yeah, don't slow down to see the cops. That means you're guilty.
I think everyone does that.
And
If
then-
that line would have went straight down, I would have said they hit something.
In part 3, I drive through the construction zone.
Stupid construction.
And then in part 4,
It's everything.
I would accelerate, but I'm not accelerating up to highway speed, so maybe I'm in town now. So I accelerate to town speed. Or maybe city speed. And then I drive through the town. That would be part 5. So drive through town. And then part 6 is I arrive
Yeah.
at my destination, right? Because
Yeah,
I'm
yeah.
slowing down to a stop.
If it would have went like, I would have said you hit something.
Someone did something massive just by turn off onto Golden Road. It's just like huge, just red, like there's tracks and then just red mark. I'm like, that was a moose. Poor people.
That's actually a cow.
Okay, so if I look at the next one, I have speed versus time again. But what's happening?
Jumping.
Could
Speed increases and then comes to a stop.
Could be like a swing.
Increases, comes
That's
to a
like
stop.
freeway
Could be
driving.
a swing.
It could be a swing.
That could be like on a freeway because you speed up and then you slow down. You speed up and then you slow down.
Or maybe like.
But you're coming to an actual stop.
Maybe
Yeah, you
it's like
stop
lights,
a lot.
Traffic light.
Trust me, when you're Nana,
It could be for traffic lights.
or
I
just
think
the
I
stop
like the
signs
speed
in
sign.
Fairview, because apparently they're everywhere.
Or stop sign.
Coming up to a stop sign, especially if you have a series of stop signs in a row, that could be it.
You're hitting a whole bunch of stuff.
You're hitting a whole bunch of stuff.
Tree.
Bumper cars.
Driving on Halloween.
There we go. The book says a pendulum swinging back and forth, but I'm not really sure how that.
Because
Because
like
this
it
is
goes,
showing
it,
some
it has to
increase in
stop
speed.
a bit and then it swings
Goes down.
That's
It's
why.
not-
That's
Oh
why I
yeah,
said a
that would
swing.
work.
That's why I
A
said
swing.
it.
So
Yeah.
a swing or a pendulum. I guess I spelled pendulum wrong. Nope.
Make my slash very bad.
Okay. So it's like the last examples. This time you have to sketch the graph. So in this scenario, you're going to sketch a graph. There's no scale, so we don't need to worry about what your markers are. We want the oven temperature when baking a pie. Okay? So time's going to increase, and then the oven temperature.
It's gonna increase.
So what ends up happening?
Well, you got a pretty deep oven, so it's gonna go
Okay.
up.
Is it going to start at 0?
Yes.
Maybe.
Really?
No, I guess not. Because that would be
Well,
freezing.
Is
The,
it
ins-
gonna-
the
is this-
inside of the oven, is it at 0 degrees
It's
Celsius?
at room
Freezing.
temperature.
Okay, so it's going to be not at the origin. So then what's going to happen? The temperature is going to increase.
Time is going to.
Okay. Is it going to increase at a constant rate?
Yeah.
Generally. Okay, so I would draw it as a straight line. Then what happens?
Levels off
It levels off.
for most.
Okay. The ovens are controlled in such a way that the temperature should remain constant. If it fluctuates a degree, it automatically starts to heat it up. So we could draw this as a straight line. You could draw it kind of a little bit of a wavy, but not very much. The temperature would stay relatively consistent. Okay? And then what happens when the pie's done?
Slowly cool.
Slowly cools down, and does it come right back down to the axis?
No.
No, it's going to cool down. And is it going to cool down as fast as it heated up? No, so this line here has to be a lot shallower, and then it will level off again. Okay? Ben is running in a 100-meter sprint. So we have his speed and we have his time. So will this start at the origin? Yeah, because he's not moving when the gun goes off for him to start running.
Give a full lap and go.
Okay, so then what ends up happening?
He starts,
0
trips,
to 100.
and stays there.
No, he doesn't trip.
What?
Ah.
It's like that one. That
No,
one
he gets spiked.
video. It's like the Olympic sprinter. He's like practicing. All of a sudden, the chick
Yeah.
walks out on the track.
Listening to it,
Yeah,
you are.
whoever does, it'll just be
Okay.
like quiet and muffled voices.
We should walk up there.
So what happens at point 0?
He's
He's
ready.
he's at
He
the starting
starts
line.
running, okay? So when he starts running, his speed is going to do what?
Decrease.
Increase.
Increase. Is
Sure,
it going to
backwards.
increase consistently?
That shit.
Is it backwards?
Yeah.
Look at that.
No, it's not going to happen in, like he's going to start off kind of a little bit slow while he pushes himself off, and then he's going to get faster. So my line is not going to be so much a line as it is kind of a curve.
It's gonna drop.
Now, is his speed going to keep continuing?
No.
No, what's going to happen?
He's gonna
That's the
finish.
same.
It's going to level out, or it should level out. Or maybe it kind of maybe goes down just a little bit, and then what happens?
He stops coming.
Does he stop completely?
No, he
No,
slows.
you run through the finish line.
Okay,
No, you
and when
stop
he
after
slows
that.
down, is it going to be a fast slow down or is it going to be like,
It's
is it going
gonna
to
be
take
very
more?
abrupt.
Take
They
a
put a
while.
big, like the jump mats there and just run.
Well, it's 100
It's a
meters.
brick wall.
Is that a long sprint?
No.
Yes, it is. So he's going to come to a stop. It's not like a marathon, or well, not a marathon, sorry. It's not like maybe like a 400 or a 1200 where maybe he slows down and doesn't come to an abrupt stop and he kind of walks it out a little bit to let his body cool down before he starts to take off. Or before he stops, I guess. Okay, your question.